My name's Eric Mosier. I'm from Duluth, Minnesota. I own solid rock masonry up in Duluth, and I build masonry heaters and ovens, and we travel all over the country and build cores. We ship them all over the world too. We got stuff in Japan and Australia and that. Real small, mostly designs, but we do ship doors, everything else like that around. But kind of my background, not very many people know about masonry heaters here in the United States and Canada. They come from Europe. Most people over there live with them, or anybody who's been in the service or who's lived over there in Germany, Austria, anything like that, they've seen them over there. How I came about to learn about masonry heaters, I was building a big brick house, and I remember seeing an old guy go down in the basement a couple of times a week, and he comes out one day with a pan of cinnamon rolls he just baked in the bread oven that he had made downstairs, and I had never had any time to go down and talk to him or anything because I was running a crew of 10 guys, and he came out and gave us cinnamon rolls and said he just baked them in the oven downstairs, and asked me if I knew what a Finnish masonry heater was, and I said I had no idea what that was, and he proceeded to explain it to me. And his name was Gene Hedin. He was a Finnish mason from Duluth, and he had been, although Gene was in his late 70s at that time, and he's on dialysis twice a week, and he ended up asking me if I wanted to learn how to build these because he was too old and his nephew wasn't interested in it, and he had nobody to teach the trade to. So he asked me if I wanted to learn, and I proceeded to build a number of heaters for Gene over the years, and yeah, that's how I ended up learning about them. About 2 years into building them, he told me you need to go to this group, the Masonry Heaters Association. That's this pamphlet here, if you guys haven't gotten one yet. Says there's a group of masons that climb up on top of a mountain once a year, and they build a bunch of things and destroy things, and they do a bunch of testing and have fun. And so I started from there, and from there I've learned from some of the biggest people in the world. We have the best builders come in from Russia and Germany and Sweden, Finland, everybody comes and teaches us. So that's kind of how I learned about it. And I teach masonry heater workshops up at Northhouse Folk School up in MREA, and then at other folk schools across the country too. It's kind of my background. As far as masonry heaters, for anybody who doesn't know, masonry heaters uses wood. You put a load of wood in, you burn it super hot, super fast, goes through a system of channels or chambers, depending on what type of system you're building. Then that whole masonry mass heats up and stores the heat for the next 12 to 24, 36 hours, depending on how much mass you end up putting into the unit. This here is a typical German type stove where it's channeled. Masonry heaters are in a class by themselves when it comes to burning clean. We burn cleaner than pellet stoves. We burn clean. We have stoves now that are burning at net zero. We're actually making charcoal net with them now. So you can turn the stove down at night, and you end up with a couple pounds of charcoal left over at night. You can use for putting in your garden or whatever you want. So we're actually burning wood cleaner than if it was to fall down in the forest and decay. As far as the energy efficiency of a masonry heater, you end up sizing the masonry stove to fit either the room that you're looking at building, or otherwise the house. Most masonry heaters can be built big enough to heat about 2,000, 2,500 square feet with one stove. Usually if you go bigger than that, we usually end up putting two stoves on the, one on the main floor, one on the second floor. Really big homes, we put 3 in, depending on the stove. I'm fairly open as far as questions too as we're going along. Anybody have any questions or comments? Feel free to shout them out during the workshop. You're going to forget by the time we're done.
So as it's burning, is it gasifying the wood?
Oh yeah, it gasifies the wood. Yep. Yeah. No, because our firebox temperature is usually at right around 1,800 to 2,000 degrees. So everything that will burn in wood burns up. Yep, you're at like 98.5% efficient on combustion efficiency. Overall efficiency, we're usually at about max on a masonry stove is about 85%, and that's anybody who says anything any higher, they're playing with numbers. 85 is about the max because you're gonna end up losing 15% efficiency on just the moisture content in your wood, and anything you're gonna lose a percent or two on design, something like that.
Is there a fan that feeds it, or is it just fed by a fan?
No, it's all radiant. As far as the draft is all natural draft. No, if the heater's designed properly, nothing should ever have a fan blowing into it or anything like that. No, the fan actually cools down. If you're trying to blow through it, it actually makes a cooling effect in the house, so we usually don't recommend fans.
Pulling outside air or inside air?
Inside air normally. Some local areas require you to have outside air coming in. I will say put the outside air in, but make sure you can get at it and shove some insulation in it after the inspector's gone, because it's actually, we've proven it to not decompress a house, even the tightest of houses, and the outside combustion air doesn't work all the time. If you have it coming in on the east side of the house, you get a westward wind, you have positive pressure on the outside, and it doesn't work. We've actually, one of my colleagues up in Canada actually has pictures of one of his heaters where the smoke is coming out the side of his house from the reversal, coming out the fresh air intake. So we say to put it in where you need to for code purposes, but make sure you can either put a damper on it or shut it down, because they're not required. Or you don't need them.
What are the pros and cons of a wood-fired stove? 'Cause I'm debating one or the other.
Oh, as far as like a wood-fired stove, like a typical cast iron stove, something like that.
Right.
With those, how people operate those in everywhere is you load it up, get it burning, then you damper it down, and you get 12-hour or 24-hour burns. The only thing you're doing is smoldering wood, and when you smolder it like that, you got incomplete combustion, you create tars, and obviously that's where all the chimney fires come from in the United States and Canada too. As far as the heat-wise, with a wood stove, you always have to be firing it, loading it constantly to get any heat out. The temperatures on those are going to be at 500 degrees or hotter, even 800 degrees, 900 degrees, which obviously isn't very good for you. Kids, everybody can get burnt on it. As far as it's dust that's flying around in the air, lands on it, burns. Not very healthy, and as far as the ions in the air, it totally changes the ions in the air because of how hot it is around that area. Whereas with a masonry heater, you design it, say a 1,000 square foot house is 30 pounds of wood usually. You throw that in, burn it, it's gone in an hour or two, and you close the damper down, and that's it for the next 24 hours. And the outside surface of most masonry is going to get up to about 150, 180 degrees at the absolute hottest, and it's going to stay that way for 8 hours or so, and then 24 hours later you're still at over 100 degrees on the outside of the surface. So as far as health-wise, it's a much better environment for you. A masonry heater is radiant heat, so it actually uses the same wavelength as the heat's the same wavelength as the sun. So as far as health purposes go.
So is it only radiating in the air or also on the floor?
Radiates, it's heating up objects is what it's doing. So it's your cooler in here. You go outside, you stand in the sun, it's going to be hotter. Same thing is with your bedroom. So your bedroom's going to be cooler. Say it's 72 degrees around the heater. Your bedrooms are going to be like 65 degrees, something like that.
So the floor would be a little warmer?
Yeah, because it's heating up the objects, everything in the floor. It's just like the sun does. So it's like going and sitting on a hot rock on a warm day in the sun. So that is what it's doing.
And if the temperature changes quickly outside, you just open windows?
Oh, you mean inside? Oh, as far as that. Yeah, you open windows if you have to. Otherwise, you kind of look at you kind of plan ahead. Yeah, don't put two fires in it if it's not, if it's not going to be below zero. It'll get you in the spring and that where it sneaks up on you sometimes. If it gets into the 50s or something, and you put a full fire, and it does get a little warm sometimes. But if you were to plan ahead, you wouldn't throw 60 pounds of wood in. You'd throw 50 pounds. Yeah. You'd just throw in less wood the day before. Yep. Negative ions are good for you. I mean, you wouldn't think of it, but that way. But that's the way ions work within. Tuulikivi is a company out of Finland. They've done a lot of studies on this. You can go on their webpage, which is there's links on brochures to that. It's just a feeling of well-being with it. Whereas when your air gets super hot from a wood stove, like a cast iron stove, because it's frying the molecules in the air because it's so hot, and that gives you. That's why when you're in a house with a wood stove, you just kind of feel like slow and lethargic. Whereas a masonry heater, people can feel the difference.
Can masonry designs be used for making a wood cook stove with like the cast iron cook top laid into the masonry?
Oh yeah,
Or-
yeah, we do that all the time.
Oh, and you can still have an oven despite it holding the lower heat?
Yep. Yeah, the way you design it, you can right above the firebox, you can have the cook stove, and then that goes into a masonry mass and a bake oven too, even. Yep. Yep. On the picture there's a bake oven up above on that one. Yep. Kind of the evolution of masonry heaters. 3 stone rocks. Once mankind started figuring out, that fire heats up rocks, they started piling more rocks up on top of it, and they could bake more evenly. And then all of a sudden, hey, the fire's out, but the rocks are still heating up. So they started messing around with it. The main history of heating masonry like that dates back about 10,000 years ago. In Afghanistan, they were heating floors with that. That transferred into, just from the Silk Road and everything like that, into China, Korea. The Romans eventually came over there. The Romans brought that up into Northern Europe, and that kind of channeling masonry that way kind of spread up into it that way.
Have you done a stove that does both heating the atmosphere and the floor?
Yeah. Yeah. Well, it heats the floor itself, but otherwise I do have some clients who we install hot water coils into the fireboxes. You can take up to 60% of the energy out of the load of wood in, and put that into either the floor system, otherwise into radiant systems. That is something I can't do, but I have you design, have a steam fitter design all that. Yep. Most of the old masonry heaters were basically just uninsulated bake ovens. So the same type of cob oven you might see built here. Don't put any insulation on it basically, and that's what they used to use for heating. They have designs like that all over Northern Europe, Finland, Russia, Germany, everywhere. They basically started figuring out once you start adding channels onto it, the more channels you added onto it, you took more heat out of that wood. So you started with, say, 1800 degrees, by the time you're done with the channels, you're at 250, on a well-designed stove. So you're always trying to keep the exhaust temperature at about 300 degrees, otherwise it'll start to condense. Even if it does condense, we've proven that it still burns clean. Even if you have water coming out of the end of the stovepipe and you're at 90 degrees, it's still clean because everything's been burned up in the firebox. All the hydrocarbons, everything. That's just an old stone oven in Finland, soapstone. Kind of the transformation of ovens, saunas, everything like that into a masonry heater. You heat up a pile of rocks and bricks, and you have heat that lasts. Back in the 1500s to 1800s, there was what they call the Little Ice Age over in England. There started to get to be a lot of people. The population was going up. Wood and coal were basically the only forms of heat that they had. They ended up being too many people. Wood was starting to run out, so some of the kings started getting a little nervous, and so they had a contest for somebody to invent something that didn't burn as much wood. So I guess they ended up having contests, and that's where some of the designs today that we still use have come from. The winner was actually this bottom one down here, what we call the Swedish 5-run design, and we still teach that at our workshops and use that.
What's that called?
The Swedish 5-run was the winner back then. There's stoves that are much more efficient than that still nowadays. Yep. Most of the every stove over in Europe, that's anybody that's under the euro who builds a stove. So if you're in the UK, Germany, Austria, Finland, anything like that, everything over there has to be built according to the Austrian calculation method. We're getting to that here now, but that's where most of these stoves actually originated. Most of it was rules of thumb. You start with this, and you get a little bit smaller every channel you go. They took that obviously quite a bit differently, and you know, hooked up fluid dynamics to it, and you end up getting something that they calculate everything out to, so that they know that it works on every design, and every heater that's built over there now has to be built according to that method. We're not at that yet here because we're not regulated. The EPA is looking at regulating. The EPA was looking at regulating us or leaving us alone last year, or the last couple of years. There's a wood stoves going through what happened about 20 years ago, the new source performance standards, where it wiped out about half the wood stoves companies in the United States, where they're just looking at lowering emissions. They already know that we burn clean, but there was a number of us members that wanted masonry heaters to be regulated just with EPA standards, so that we could go into California, Colorado, other places where it is regulated, where you can only burn an EPA wood stove, so that they could do that. In order to do that, we're looking at doing the same type of calculation system that the Austrians use, but we don't build stoves the same way that they do. We use different materials, and most of us don't build a channeled system, which is the Austrian or the German calculated system. We build Finnish Contraflows, otherwise the new Russian bell systems, which is, I'll get to. Finnish Contraflow is fairly simple. It's what a lot of the builders in the United States build and teach. United States and Canada, sorry. Simple system. Fire goes straight up. It either goes through the oven. If it's going through the bake oven, we call that a black oven, because on older designs it did get black. Now if you have a good design, it'll be a gray oven, or it'll just be fly ash that stays up in there. Otherwise, you can direct the heat around the oven. You never have to worry about the smoke and the fly ash if you don't want that in your oven. We call it a white oven just because it stays clean all the time, unless if you boil over your food and burn stuff on it. What it does is goes up into basically that oven. You have the oven here, then it comes up into another chamber. Basically, we consider those bells nowadays. I'll get to that when we cover the Russian bell system. Then it always splits and then goes down a channel on both sides of the heaters evenly, and that's where they get the Contraflow name out of it. It's funny that we call it the Finnish Contraflow. That's the main heater that they build in Finland. And if you know the history between the Finns and the Swedes, the Swedes actually invented the system. They didn't like it, and the Finns took it on, and it's become their system for some reason. Yep.
On lighting a stove and a wood stove or whatever, sometimes I have trouble getting the draft going on it.
Yep.
How does it work on these? I mean, it seems like it'd be a lot harder because it's got to go up, down, around.
You would think, but actually before you even get to the chimney, I can have up to 80 feet of channeling, like in a big German heater, before I even get to it, and there's no issue at all.
The draw just goes.
Yep. Yeah.
What helps drawing the air?
As far as it's all natural draft, so the heater has to be designed, properly as far as either with the channels, otherwise with the chambers that you end up building. Your chimneys, obviously, has part of it, part to do with it. If you only have a 10-foot high chimney, you're not going to have as much draft, so you have to accommodate that with the design and have some flexibility. If you have a really small, short chimney, single-story house or something like that, or a real small cabin, you're not going to want to necessarily go with a calculated heater. You're going to want to go with a different type of heater, and that's usually your builder's going to, or is going to do something like that. Otherwise, you go online and find a designer who can design like a Russian bell heater or something like that, because they work on a different set of principles. It's a free gas movement. I'll get to it. But we have found through testing in that these Finnish units that have been around for hundreds of years work on the same type of principles that the Russians figured out about 100 years ago with the system of free gas movement. As far as if you look at most of these masonry heaters, the best place to locate the heater is in the central part of the house. Doesn't always happen. They work really well like as room dividers between the living room, dining room, and the kitchen. So you can have the oven on the backside if you're looking to have that, or a cook stove on the backside, something like that.
How much wood is that 60 pounds of wood shown in that picture there, or is it? What kind of volume are we talking about for feeding the?
That's a little bit more. If you were to look at the firebox, you're gonna usually looking at filling it about 3/4 full is what you're looking at doing. So on this, it's usually about 12 logs, something like that.
Okay,
12 split logs is 60 pounds. 18 inches.
18?
Yeah, 16, 18. Yep. No, there's a system. You don't want to get you look at old fireplaces and they were designed really bad with too wide, too deep and you didn't get very good combustion temperatures at all in them, and that's why we always try to keep it compact. I might go out to 32 inches on a really big firebox or something like that, but I'm only going to be 14 inches deep. It's just so that there's some ratios you have to stick in on that with that. But as far as design, this typical 6 foot high wood box, something like that, is going to something like that's going to be at least a week and a half worth of wood. Those typical wood rings that you see out there on like a 2,000 square foot house, that's usually a week's worth of wood. It could be 2 weeks worth of wood if it's above zero usually. As far as design goes, you can get heaters to fit into corners. This is like a bay type unit where you have a flat side and then it comes back and angles back on all sides. You can make them round or oval too.
But he's also got a cooktop and an oven attached to that, correct?
Yep, correct. Yep. Yeah, they use the cooktop kind of in the spring and in the fall quite a bit, and there are channels within. I build those to actually heat up, so that whole mass does heat up too. You do have to have a separate flue for each one of those. So.
You have a lot of different shapes. Your orientation, since the heat's coming off perpendicular to the surfaces,
Yep.
Can you actually design them so that you can throw heat to different areas of the
Correct.
structure?
Yeah, and that's where, depending on how the Germans get real anal with design that way, because if you look at a typical one, you're never going to see just a rectangle. They'll make round ones because the heat does go off in straight lines. Yeah. So when you either curve it or you angle all sides of it so that it's going off, it might be splitting hairs, but because the heat will get there convectively. It's just, if this is a corner, you're going to be cool and you're going to be hotter. You know what I mean? It's how much? I mean, is it a half a degree? Or I haven't done any testing that way, but I'm sure the Germans have. They do quite a bit of testing on that stuff. But yeah. Yeah, no, that's why we build oval heaters and round heaters and 6-sided, 5-sided heaters, just to kind of, it does help with that as far as aesthetically people like that too, but it does help with the heat transfer in that too.
So do you design the heater or the mast based on the home design? Or?
On the home design, yep. Mm-hmm. Yeah, so we'll start with how big of a place are you trying to heat? And we'll size the firebox to that, and then that has to get balanced out with the mass of the unit, because just because you have a 30-pound firebox, you can have 50 square feet or 150 square feet of stone, you know what I mean, to go, or of masonry to go with that, depending on the design. So, but there is a balance between that.
I'm dying to hear what the prices are when we get to that.
Yep.
I know with the cast iron stoves, there's certain types of wood you can burn, and generally you have to clean them. How does that apply to the masonry heater?
With masonry, you can burn any wood, but you do want dry wood. That's the main thing with everything. Even with a wood stove, you should be burning dry wood. Everything will burn cleaner and hotter as far as that goes. I know there's a lot of different theories with wood stoves. I know people who burn wet wood or put big logs on, but because it burns slower. But burning slower decreases your temperatures and makes it dirty, and then that's where you get the creosote in your wood stoves. With a masonry heater, wherever there's a horizontal channel, you'll end up having to vacuum that out once a year. So you either vacuum it out or reach a brush in there, a little rake. The hole's usually about 4.5 inches. So usually a shot back. Otherwise, just you reach in a special brush to get to the back of that. Pretty much all you got to do.
So no need for a real chimney sweep.
Normally, no. All my clients, I will say to, have it swept out once a year, and then go off of the schedule as far as what you'll find. Most of the times, they burn so clean that most of the time it's 8 years, 10 years between cleanings, and even then, they're lucky to get a coffee can worth of soot out of there. There'll be a lining of fly ash in the chimney 8 years later, and that's pretty much about it. But yeah, it does help a little bit with the efficiency in the draft. But if you're burning wet wood, obviously you can. I have had 2 clients in 15 years get creosote on their glass, but it was always one was during the curing stage, and it ended up burning off. But both of them had wet wood. That's always the biggest learning curve with most people. Is the first year they get bad wood, or they get wood that the wood guy said was cured, and yeah. Yeah. No, with everything, you want to get your wood a year ahead of time in advance, especially if oak is all you have access to, which you do down around here a lot, and oak usually takes 2 years to really dry out. That's cut and split and put underneath a tarp, not just cut down into 8-foot lengths. Yep.
How do you support these? I assume they're going to be on the first floor, and there might be a basement below.
First floor, if you end up having a basement underneath, you can either put in post jacks and then steel I-beams to support up to about a 9,000 pound. I wouldn't go much more than that. Otherwise, concrete block.
All the way up to the...
Yeah, just in the basement. Yeah, just a foundation. It doesn't have to be solid. You can make it a U shape and span it with an I-beam across the front, so you can have like a closet downstairs. I have a lot of people put in safes, everything like that, down in the basement, or they make that their where they stack like a pantry area, stuff like that.
Safe room.
It's very good safe room, yeah. A lot of people do that, yep. Otherwise, I've installed a lot of heaters on just 4 inches of concrete, too. Solid concrete, as long as it's solid, yeah.
So like slab on grade is okay.
Slab on grade. Yeah, if it's new, I would always go with a 6-inch or an 8-inch slab, but I've installed, I don't know, probably 50, 60 units just on 4 inches, and there's no cracking in the floors, anything like that. It's just, even on an 8,000 pound unit, you're only at about 5 psi as far as what what it's putting down for pressure onto that concrete. So as long as you know it's good. If it's an old, farmhouse and it might be 3 inches here, but 1 inch, on the other side, it's always drill down into your corners and make sure if it's an old concrete slab. Otherwise, you might just have to, cut it out and just pour a new slab underneath there. Yep. Here's an old Russian vertical channel heater. A lot of these were built and still are built in some areas. The issue with this is having that firebox like this. These do end up, they're not replaceable, so they end up falling apart over time. I know one of the guys, there was a Russian, Lepeshenko, who kind of started the movement about 35, 40 years ago in the United States. He was building some over on the East Coast. Albie Barden found out about him, came and learned from him. Albie found out, or he took it. He wanted to do this. He owned Maine Wood Heat over in Maine, he went over to Finland and studied with Heikki Heitinen, who was the leading guy in Finland at the time. And Heikki helped him write a book, and Albie took that back over here, and then he started teaching some workshops on it. And from those first few workshops, that's where masonry heaters were kind of born in the United States. There's always been a few immigrants, you know, Russian, German immigrants, stuff like that, that built them every once in a while all over the place, but that's where the main movement kind of got started here in the United States, and that was only about 30 years ago, so not that long ago.
So what is the life expectancy of masonry?
Probably at least like 900 years, yeah, something like that. Yeah, as long as you make the firebox replaceable.
Do you have data on that?
Yes, we do. Yeah. Yeah, I have colleagues he has them dated. The tiles were dated over, I think, 500 years ago. So, yeah. But it's the firebox that's going to go out. The old ones, obviously, they didn't make them replaceable. We started making them replaceable about 15 years ago in the States here. And so you basically have, you have an outer layer of firebrick right here, and then you have this inner layer of firebrick, and that inner layer that's what'll go out on you in 15 years, 10 years if you mistreat it. Most of them are going to last 50 to 75 years before they need replacement. So all layers of that, even the firebox floor here is replaceable. 'Cause that's usually what's going to go out is the floor and then that back wall. We build all of our throats out of firebrick. Most of the time, the throat is where the fire is you're getting the Venturi effect, and it's speeding it up, mixes gases up. When you're at that place, firebrick is really good for that. Otherwise, there's some. I've switched over on some of our designs to ceramic kiln shelves. They're carbide though. They're expensive, but they're pretty indestructible. I create them free floating, and with that, that can be removed from the inside. So now everything that's basically ever going to go out in the masonry heater is replaceable now. Yep. But switching to that ceramic kiln shelf, for years and years, the only thing we've ever been using in ovens, that's what's in this oven too, is either cast refractory cement. It's just a high temperature concrete. It's like a 3,000 degree concrete, or firebrick slabs. That's what I was taught. That's what everybody's been using, and I kept getting clients who were complaining, you know, this oven only gets to 350 degrees on one fire, and I'm like, well, that's the way it is, and you have to use 2 fires in it to get up to 500 degrees for like baking bread. So 350 is fine for slow cooking stuff like that, but people want to bake bread and not have to have 2 fires a day, and I usually only need 2 fires a day if it's below 0 out, and not all areas of the world get to that. You know, if you're from southern Missouri, you're almost never going to have 2 fires a day. So I started messing around with materials. I switched to right off the bat, I got lucky. I asked one of my refractory companies and said, try this kiln shelf, and put that kiln shelf on, and I put a piece of soapstone on there to get to about 2 inches of mass on there, and I get 700 degrees in 45 minutes on a fire. So 700 degrees is about what you want for baking pizzas, stuff like that, flatbreads, everything like that. And then with the baking in a masonry oven, you're going to have, so in a properly designed white oven, you're going to have 600, 700 degrees during the fire. Hour later, you're going to have 550. Hour later, 450. So you kind of do your baking as far as timing that way. This is mainly shown for historical. But a lot of these designs are, I know that the fireboxes are starting to fall apart just because it's not replaceable. And it's a shallow firebox too, so it doesn't burn quite as clean as the taller ones do. So
It
usually,
doesn't burn quite as clean. How do you get the whiskey that's clean?
as far as it's not burning as clean, you're still, everywhere there's a flat area, there was always an area to go in there and clean out. always. And those were also the areas that the old masons would stick bricks into until the final payment cleared. Then they would tell the clients to go in and take the bricks out of this one area, and it would work properly once they got paid. So this is the Russian bell system. Evolved about 80, 90 years ago. I can't even say the Russian guy's name that developed it. But Igor Kuznetsov is kind of the head of it right now over in Russia. And he's designed 20,000 stoves with this type of system now over there. But it basically takes all those channels you saw in like some of the German type heaters, and basically just made them a big chamber is what you do. There's a system of rules you have to follow with it. Big chamber. Well, let's see. What it does, the hot gases go up to the top, just thermodynamics. Once they start to cool, they sink, and you always have your exit down on the bottom. So hot air, gases move up, they sink, and then they work really well that way. They actually work better than the majority of all the other units do for some reason, because they work on a different, like if you were try to run a Russian heater in this type of heat and a German style heater head to head when it's this type of heat, the Russian heater would actually be able to work, whereas the German stove would never work because the pressures were not there with the differential just to get your draft going. So there's a lot of masons here in the States and that are switching over to that. They still can't legally build these wherever in Europe yet, except for in Russia, just because everything's under that ruling with the. So we're doing with the EPA is we're working on a set of calculations just like they have with the Russian systems or the German systems, but we're doing it to include this type of system, which it's not easy to do. We actually somehow we've gotten some of the best. There's engineers and physicists that have gotten on because we're doing it open source right now. So they're coming on. There's guys that I would never even have thought would come with us, guys who design stoves for countries and stuff like that, that are coming in and helping us out with this to get this calculation system running.
So that Russian thing, it's just a big chamber.
Just a big chamber.
And then just an outlet at the bottom.
Yep.
So you just
Yep.
take the coldest stuff off and just don't forget the fins,
Yep.
forget the channels.
Yep.
a big
Just
chamber.
get rid of it. Yeah, we've experimented, and you can do 4 foot, 2 foot deep. You can go 4 foot high with it. Make an 8-inch hole in the bottom, and it works
Send your
really
kid
well.
in there to clean it.
Yeah. Yeah.
Except, yeah, it's every kid.
Yeah. Well, you just always just in the bottom. You just make a little hole in the bottom. You can always get to it usually. So. Yeah.
Each generation, one of the kids gets sent in.
Yep.
So where does it exit? I mean, is it still a chimney, or is it?
Yeah, it exits always into a chimney. Yep. Yeah. Yeah, this is the first. This is one bell right off the main firebox. That spills over into a second bell right here, and then this little hole right there is the chimney that's going up. That's where this is right here. Then.
So is it cool that the bells are getting smaller?
Not necessarily. They don't have to get smaller. It's just the way it is on this design. Yep. No, they can all be the same size, and yep. And I've made like 3-story units with some of these. They get fairly complicated with dampers and whatnot, but
Can you do an oven on one of these?
yeah. Yep. Yeah, the oven always has to be located right above the firebox, though, to get it to the best temperatures. We've tried them in different locations over the years. I would never do it again. A lot of designs are like that too, but if I'm going for a design, I don't want it to get. I could care less about 350 myself. I want it to be able to get to 500 at minimum to 700 degrees for baking. Yes, sir.
How high did you say you have made that stove?
3 stories. With,
3 stories.
yeah, it's a 3-story bell. Yeah. Yep. I had Alex Chernov up he's out of Toronto. Alex is from the Ukraine, and he actually he studied with Igor for a number of years. He came over. He was actually a banker and he did some masonry work over in Ukraine, and he came over and immigrated to Toronto because of what was going on in just with unrest and that over there. And I remember when Alex came to the first Masonry Heater Association meeting. There's a lot of old German guys there and that, and he did a presentation on it and how they work in that, and how he drew these big bells and how the hot air fills up, and he had his channel, had it coming in here, had it coming in, had an exit there, and they just totally ripped him apart. And I'm very glad I was not Alex that first night, because he was just it was horrible. But what was funny was when he went and built it, it worked faster and it actually burnt clean within 10 minutes of being very wet masonry. Like when we build at these things, they go up very fast because it's all, you got 4 masons working on one stove, and they go up very wet, so they don't burn clean very fast because everything's really wet. And that stove actually was burning clean within 10 minutes. And I think we had Heike over at the same time, and he was teaching a workshop on his new clean burning firebox, and he couldn't even get his burning clean for like 2 hours or something like that. So it was very interesting to watch that play out. But Alex ended up disproving, basically most of all those things, and he went over to Austria and tested with some of the big groups over there. They obviously don't want it to go through because the calculation program is ruled by Kachelofen brand and a bunch of other companies that have computer systems for it, because it's about 2 days worth of calculations to design a stove. They have it on computer simulation now, so you can punch everything in, but there's obviously, it's a couple $1,000s to buy into it and $600 of licensing a year, so they make a lot of money off of it. So they obviously don't want us to put this free system out, basically. So.
Can you integrate radiant floor heating to heat some of the extremity bedrooms that might be?
Some of them. Usually the floor is one thing, but we usually end up putting it into radiators. Works a little bit better. It's not gonna. You'll be able to. It's not going to be able to heat up big floor systems, anything like that. You'll be able to, preheat and stuff like that and raise that up, but you're still going to more than likely need another boiler to finish it off. Yep, that's on bigger houses, stuff like that. But radiators are smaller, so they end up doing a real good job heating with radiators.
How would you heat areas that are isolated from the actual stove?
Either with radiators, otherwise if you're 40 feet away, it's going to be, low 60s or the high 50s. So it all depends. Most people want their bedrooms in that low 60s. I would never want to sleep in a 70-degree bedroom, but that's usually what you end up doing. Otherwise, you do like a cheaper supplemental heat or something like that. So like an electric radiant that'll go on if it doesn't get up to temperature.
Is there any problem with super insulated homes and getting that air in?
Not getting the air. Nope. They've been tested in the tightest of R2000 standards up in Canada. Norbert's done testing up there to not decompress a house. And those standards are some of the most stringent anywhere.
Yeah, can a competent amateur do this?
Yeah, I teach
And
people.
How do you get is there a source to get the calculations and figure out the opening sizes, etc.?
No, you're not going to get that. Somebody else will design it, because otherwise there's just too many years of experience you're going to have to know to do anything with that. So yeah.
Do you have to take particular care for fire safety if you're running temperatures way hotter?
Everything proper clearances, so you shouldn't have to, as long as it's built according to how it's designed. That's where everything starts. You got to have, there's rules that you have to follow with that. We're not kind of getting into that right now, but that's something who somebody designs will let you know, or a kit that you buy or something like that. Yep. Here you can see the hot water loop, onto the side, right in the firebox there on this bell heater. And I started, instead of doing all of our bells in brick like this, which take an absolute enormous amount of time because there's lots of cuts involved, I just started those big chambers off to the side. I just started using really big clay tiles because they come in 1 3/4 inch thicknesses, and you can kind of make them whatever thickness or however depth you want, because they come 24 by 24s. So I don't have a picture of that because I just finished one here a week ago in it, but I didn't get it on the slideshow. Here's an old Swedish tile stove. It's on a Swedish stove. They're going up, splitting and going down the front and then coming up the back end. Most of these are pretty big units. I have installed units that are, you know, like 12 feet high on these. They get pretty big on them. Couple other ones.
What would you actually see going through the roof? Do you run masonry to a certain height and convert over to steel, or?
You can run masonry. Usually I'll run it for the first 8 feet, 9 feet in height. After that, you're not going to get any more heat out of. It's going to start cool. The gases are cooling down too much to get out that 4 inches of masonry. So I'll usually switch into steel after that. So depending on if you have a vaulted ceiling, you just go with a close clearance pipe, and then always when you go through, I always switch to Class A. You can run masonry all the way up through if you want to. That's just design-wise, but it's not needed.
So you could conceivably replace a freestanding wood burning stove with this.
Oh, yeah.
And use the same chimney
Yep.
system.
You're going to need a firebox that's 30 pounds or less to fit into like a 6-inch flue, which is what most wood stoves are. After that, you're going to move up to an 8-inch flue for most of the bigger fireboxes. 8-inch flue, or otherwise some of the older clay liners are 8 by 12, and those will work. The 8 by 8s won't work. It's not big enough, even though you might think that it's 8 by 8, but smoke travels in a circle and it's not using the corners, so it doesn't use all the on a square liner. Here's a couple of the German and Austrian tile stoves. Yeah, very ornate. Most of them take about, a month to 2 months to build. There's always a potter who makes the tiles, and they always work with a stove fitter to build the tiles. They usually don't do both for some reason, and I've seen that everywhere. Even there's one tile stove fitter up in Canada right now. She's the only one that I know who's building custom ones, and she flies in. The guy she originally trained with from Germany, and Mario flies in for every build wherever she's at to build the inside of the stove with her. The only difference between basically a Kachelofen, if you look at most of the Kachelofen, Kachelofen is the tile, ofen is the stove part. You'll always see they're standing up on legs. That's basically just to get another area for heat out of the bottom, because that floor is heating up. So, the floor of the masonry is heating up. So they lifted them up off the ground. Just a little bit more efficiency. And the Grundofen is just ground heater, and they were bigger, and they basically operated more with, historically, they operate them with a big door that cracked open to let the air in on them.
So those are all separate channels coming up through there.
Yep.
Fireboxes down below. And
Yeah, this is on a real big stove here. 32-inch wide firebox on this one. It shoots up here, goes down, up, down, up, down, up, down. Yep. Yeah, that's the one we have right around 80 feet of channel on it before it even gets to the chimney. Yeah. Those I always downsize the chimneys. Even though it requires an 8-inch, I always usually put on at least a 7-inch, because it's just too much draft most of the time. It'll take a newspaper right out of your hand most of the time. Yeah. That's that big stove. These are old non-gasketed doors we used to use. Here's a domestic hot water system. 2 different ways to do it just for domestic hot water. If you go into trying to heat floor systems and that, I have to bow out, because that's, according to EPA, that's become regulated once you start. You're now a wood boiler, and you become regulated, and I'm not trained for any of that. So EPA pointed that out to us, and he was looking at me, I remember, because he's seen a bunch of my pictures, and you are regulated once your clients switch into heating floor systems. But there's a thermosiphon method. Basically, there's a set of rules. I don't know them. I'm not going to teach you them. But they basically, you have to have it a certain height and a certain distance away, and it works just by, you know, hot water moving through the thing, and it moves through on itself without a pump. Then there's a circulation pump method. And the main thing is with any of them, right when the hot water comes outside, you always got to have blow-off valves on it right outside the heater. Don't put it anywhere else, and then make sure that goes to a drain someplace, because it will blow off every once in a while. We always try to maintain that temperature at about 180 degrees when it exits. You're usually going to need about a 90-gallon tank for heat storage. So some of the different types of construction systems. You have all brick. Obviously, it's going to be cheaper. It's going to take quite a bit more time just because of all the brick you end up having to cut. Firebrick are cheap, though. Well, relatively speaking, compared to like buying a kit or something like that. And you got hybrid systems where you either make your own castings. Otherwise, there's a number of companies in the United States and Canada where you can buy kits from. Buying a kit, it's going to cost you more, but if you don't have a design, it's something that they're going to give you a step-by-steps, you know, to be able to walk you through it. Plus, they're going to be able to give you support, you know, to call and whatnot. And most of them will have YouTube videos or something like that that'll teach you how to do stuff.